So we continue with our chapter energy of physics. In our previous video we had understood the work. So we understood that work is the product of force and the displacement, and its SI unit is joule. Now we see what is energy. So I told you that I can do some work only if I've got the energy or the capacity to do that work. So that's why we can easily define energy as the capacity to do work. Okay? Energy is nothing but the capacity of doing some work. So if I've got the capacity to do work, that means I have got the energy to do the work. So that's it. When work is done by a body, its energy increases. In other words, the work done on the body is stored in the form of energy. Whenever I do any work on any body, at that time, there is a energy which I am transferring to that body. So on doing any work on the body, the energy of that body increases. Like for example, I took this duster which was placed here and I placed it over here. I put it over here. So when I did work on moving this duster from here to here, so now this body or the duster has got the capacity that it can go back to its original position by itself. That is, it has got energy to do work. Okay? So when I'm doing some work, that work gets stored in this particular body. So, in other words, the work done on the body is stored in it in form of energy. But if work is done by the body, its energy decreases. So, when this body is going to go down, then it is the body which has done work, because I didn't do any work. I did not throw it, I just released it. So when I released it, what happened? The body by itself did the work of going down. So at such a condition, what is happening? The energy of this body is decreasing. So when work is done on the body, the energy of the body increases. When the work is done by the body, then the energy of the body decreases. Understood? So when somebody does the work on the body, then the body will have a stored energy in it. But when the body does the work, then the energy is given out by it, or this energy is decreasing. Like for example, if I take a spring, तो spring को मैंने दबाया, जब मैंने उसको दबाया, तो energy got stored in that spring. The moment I release it, what is going to happen? The spring is going to bounce back. The bouncing back of the spring to its original form, restoring form, that particular bouncing back is nothing but the decrease of the energy of the spring. The spring energy is going to decrease when it opens up. In other words, energy is spent when the body does work. So when the work is done on the body, the energy is stored in it. But when the body does the work, the energy is spent by the body. For example, when a girl runs a bicycle to a distance, she spends energy in doing work. Similarly, a boy playing with football runs about all over the field. He spends energy in doing work. Thus, we can define energy as follows. Energy is the capacity to do work. So when the girl was cycling, she was giving out some work done. She was doing some work, so she was using her energy. When the boy was playing with the football, so he was kicking the ball, so he is utilizing his energy. So in this way, the energy can be said to be as the capacity to do work. The capacity to do work is energy. Now the relationship between work and energy. It is experienced that more you run on a cycle, or more you run all around the playground, more you feel tired. The reason is that a lot of energy has been spent in doing work by you. Thus, to do more work, we need more amount of energy. Thus, we can say that there is a direct relationship between the work and the energy. It's a simple thing. If I am going to push something from one point to another point, as I'm pushing it, I am slowly and steadily getting tired. So my energy is getting decreased and the work is being done. So when the work is being done and my energy is decreasing, uska matlab hai there is a direct relationship between the work and energy. Okay? Jitna zyada energy use kiya, utna zyada work mila. Okay? So work and energy are directly related to each other. Similarly, the work done by the body in changing its state is said to be energy possessed by the body. So when the change of state is taking place, that is change of state means ये stationary है, उसको धक्का मारा तो ये movement आ गया, that is change in state from rest to motion or motion to rest. There also work is said to be done because energy possessed by the body is going to change. So work is done by body in changing its state is said to be energy possessed by the body. For example, if a body is moved from the ground to a height, work is done on the body against the force of gravity. And the body at the height is said to possess the energy. As I told you, that when I am moving it from here to here, I am doing the work against the gravity. The body is going to work against the gravity because gravity is trying to pull it downwards, but I am making it go upwards. So that's why I am doing the work against the gravity. So when I am doing the work against the gravity, at that time the energy which is possessed by the body is increasing. So if the body is moved from the ground to the height, work is done by the body against the force of gravity, and the body at the height is possessing energy, is said to possess energy. Similarly, if a body initially at rest is made to move, एक फुटबॉल पड़ा हो, एक लात मारा और फुटबॉल आगे गया, तो उसका मतलब क्या हुआ? You have applied force and the body started moving, so work is done, right? So now the body is in motion, so the body in motion has got energy in it. So work is done on the body and the body in motion is said to possess energy equal to the work done on the body. Till how much time will the body move? Till the work, according to the work what we have done on the football. So football पे अगर work done will be the force what is given and the displacement जितना होगा उतना ही energy football के पास आएगा. So that will be the energy possessed by the object, the moving object. So that is what we say, that when the work is done on the body and the body moves and body is in motion, then it is said that it possesses the energy equal to the work done on the body. So we can see that in other ways we say that jitna kaam kiya, jitna work done is equal to the energy, or energy is equal to work done. Okay, so we can easily say that work is equal to energy. Because whatever is the work done by me on the body is equal to the energy possessed by the body. If I took it from here to here, I did some work against the gravity, and that is exactly the energy possessed by the body over here. So work done is equal to energy. So work done is equal to energy. If work done is equal to energy, तो automatically क्या होगा? अगर ये joule में है, तो ये भी joule में ही होगा. So we see the energy is measured in the same unit as work. Therefore, the SI unit of energy is joule. Okay, so SI unit of energy is again 1 joule, and so we can say a body is said to be possess an energy of 1 joule if a force of 1 Newton moves a body by a distance of 1 meter in the direction of the force. So you see that even if we are defining the 1 joule in terms of energy, the definition of 1 joule has not changed. Here we are just saying that a body possesses the energy of 1 joule. There it was the work done by body is 1 joule. But 1 joule was what? It was just the product of 1 Newton into 1 meter. Okay. So whether I say 1 joule in energy form or 1 joule in work form, it is going to remain the same thing as 1 Newton into 1 meter. So we say that the energy is said to be at 1 joule if a force of 1 meter is going to move the body by a distance of 1 meter. 1 Newton moves a force of 1 Newton moves the body by a distance of 1 meter in the direction of force. So that is, again we see that 1 joule is equal to 1 Newton into meter. Okay, or into 1 meter. Okay. So that was about energy, the basic part. Now we are going to see the different kinds of energy. And the first thing what you're going to see in the different kind of energy is that mechanical energy. So first we are going to learn a type of energy which is mechanical energy. Now this mechanical energy is of two kinds. One is potential and another is kinetic. So this mechanical energy is of two kinds. One is potential, another is kinetic. Okay, we had heard these names when we learned the matter chapter in chemistry. We saw the kinetic theory of matter and we say that heat करने से potential energy बढ़ता, then kinetic energy बढ़ता and all those things. So yeah, this is the same thing what we are studying over here. We are now actually trying to understand what is the meaning of the word potential energy and kinetic energy. But both these are a form of energy as mechanical energy. So mechanical energy is of two forms. One is potential, other is kinetic. So we define mechanical energy as the energy possessed by a body due to its state of rest or state of motion is called as mechanical energy. So any body, any particular body which is under the state of rest or a state of motion, so whatever energy possessed by the body due to the state of rest or due to motion is nothing but mechanical energy. Okay, so energy possessed by a body due to its state of rest or its state of motion is called as mechanical energy. The mechanical energy is found in two forms. One is potential energy and other is kinetic energy. The total mechanical energy of the body is the sum of the potential energy and the kinetic energy. So, if we are talking about the mechanical energy, then the total mechanical energy of any body will be the sum of the potential energy and the kinetic energy of the body at any instance. So, जितना उसके पास potential energy और जितना kinetic energy दोनों का sum will be equal to the total mechanical energy present in a body. So the total mechanical energy of the body is the sum of the potential and kinetic energies. In figure 5.10, a car is in motion, an arrow on a stretched bow, moving arms of a clock, a rock on a high hill, a swinging pendulum, all are mechanical energy. All have mechanical energy. So, yes, a car is in motion. Due to its motion, it has got kinetic energy. A rock is at a height. वो गिर सकता है नीचे. So that's why due to its height, it has got potential energy. Bow is stretched. अगर उसको release किया तो भाग सकता है. That's why it is potential energy. Pendulum which is moving like this, तो उसके पास kinetic energy, potential energy दोनों है at different points. The moving of the alarm clock, again it has got kinetic energy as well as potential energy in the form of the spring. So all these are examples of mechanical energy. Moving car, the rock at a particular hill, the pendulum, the clock and the bow and arrow all have got mechanical energy in it. So now let us understand the potential energy in detail. So let's see what is potential energy. The potential energy is given by the letter Pe or U. Okay, Pe or U is a symbol which is given for potential energy. Potential is a Latin word which means to be able. Okay, so to be able to do some work, so that is to be able is potential. The energy possessed by a body due to its state of rest or position is called as potential energy. So when any body is in a position of state of rest or it is in a particular position like a stretched bow, बाउंडेड स्प्रिंग को कंप्रेस करके रखा है, तो स्टेज को स्ट्रेच करके रखा है, तो ये सब क्या है, एक पोजीशंस है. तो दीज पोजीशंस they are the one which are going to impart potential energy to that particular thing. So potential energy is the energy possessed by the body due to the state of rest or its changed position. So state of rest or position is called as potential energy. There is the energy stored in the body when the work has been done by a force in bringing the body to that state of rest or position. That is, work done on the body has been stored in the form of potential energy. I told you that I made this duster go from year to year, means I did one work from year to year. That work is now stored in this duster. So that work which is stored in the duster is nothing but the potential energies. Hence we see that potential energy is going to be achieved by a body when some work is done on the body so that its position or its state of rest has been changed. Okay, so that is the energy stored in the body when the work is done on that body. For example, a stretched bow has potential energy stored in it which is equal to the amount of work done in stretching the bow. When a spring is compressed, the work done in compressing the spring is stored in the spring in form of potential energy, and the compressed spring is said to be possessing the potential energy. This energy is also called as the elastic potential energy. So whenever you are changing the position, like a rubber band लिया, rubber band को stretch किया, तो stretch किया तो उसके पास अभी क्या है, elastic potential energy. मैंने spring लिया, spring को दबाया, compress किया, क्यों जब किया तो what will happen, it is going to release again. So even the rubber band, when I release it will come back to its original position. So when I am compressing the spring gets potential energy, and that energy is called as elastic potential energy. I take a bow and arrow मैंने arrow को उसमें डाल के bow को stretch किया. So the stretch condition of the bow is nothing but the potential energy, and it is called as elastic potential energy. So any particular energy which is potential energy, which is due to the changed position, not the change position, okay, the condition, the configuration, the position of the thing is changed, यानी compress किया है या stretch किया है या bow को stretch किया है, ये सब क्या है, elastic potential energy. Similarly, when a body is taken from a surface, earth surface to a height, work is said to be done on the body against the force of gravity on it. This work done is stored in the body in the form of potential energy. This energy is also called as gravitational potential energy. Thus, the water stored in the dam has the gravitational potential energy. A rock on the high hill has the potential energy. A wound up watch spring has the potential energy. So we can see that when as I told you about the duster, it was here on the ground level and then it is going up. So when I took it upwards, at that time the energy which is possessed by this duster over here is due to its height, and that is the work is done against the gravity at that time. In such a condition, the potential energy possessed by this body will be the tendency to go back to its original position, that is on the ground, that is against towards the gravity, is called as gravitational potential energy. So water which is stored in the dam, which is going to fall down from the dam and hit the turbine and rotate the turbine, is again potential energy, which is gravitational potential energy. So this also, duster at a height, ग्रेविटेशन पोटेंशियल एनर्जी, हिल के ऊपर एक माउंटेन के ऊपर एक स्टोन है जो नीचे रोल हो सकता है, अगेन इट हैज गॉट ग्रेविटेशनल पोटेंशियल एनर्जी. In the figure 4.11, a boy does work in bending the branch of a tree. This work is stored in the branch of a tree in the form of potential energy. In figure 4.11b, when the boy leaves the branch, it goes back. The work needed for the return of the branch of the tree is now obtained from the potential energy in the branch. So when the boy had pulled the branch downwards, at that time he was doing work on the branch. So the branch को क्या मिला? Potential energy मिला. The moment he releases it, the branch is coming back to its original position. So what is happening? The branch did the work of going back to its original position. So branch lost its energy, that was lost its potential energy. But how did he do that? He did it using the potential energy which was present in the branch. So boy does work in bending the branch which is stored as potential energy, and the branch does work goes back from which work is obtained from the potential energy. So there are certain examples which are given over here, very simple examples in our day-to-day life in which the kinetic and the potential energy is being utilized. So some other examples. A wound up watch spring has the potential energy because the wound up state of its coil, as the spring unwinds itself, it does work or to move the arms of the watch. Now I don't know whether you know such a kind of a watch, but if you remember or we were to the grandfather clock, the grandpa clocks, they used to have a key which you need to rotate, and when you rotate it, there is a winding of the spring. So when you rotate that, the spring gets winded up, it gets wound up, and then when you stop it, when it's completely winded and you release it, it doesn't release one at a time, it releases very 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 slowly, and then releasing of that spring makes the hands of the clock move. So that's why when you are winding that particular spring, at that time you are imparting the potential energy to the spring, and then the potential energy does work and it unwinds itself, and accordingly that unwinding causes the rotation of the arms of the clock. In figure 4.12, a compressed spring has the potential energy because of its compressed state. If a ball is placed on the compressed spring and the spring is released, the ball flies away as shown in the figure. Thus the spring does work on the ball to make it move. So you take a spring and put a ball on it, and then you release the spring. So when you release the spring, the ball is going to fly off. So flies off, why? Because the work done by the spring due to its potential energy on the ball. Actually, when the spring is compressed or wound, some work is done on the spring which is stored in the form of potential energy. That's what I told you. Similarly, the third one is a stretched rubber band has a potential energy. So when I stretch the rubber band, it has got a potential energy. It does work in restoring it back to its original position. So when I release it, it is going to restore back. But at the same time, अगर मैंने वो catapult बना के एक stone रखा, तो the stone is also going to fly off. So it does work in restoring itself into its original state. If in a pebble placed on a stretched rubber catapult, it's thrown away when it's released to restore its original state. So that's why the potential energy of the catapult is converted into the work done on the stone. In stretching the rubber band, work is done. This work is stored in the rubber band in the form of potential energy. This potential energy does work on moving the pebble. So this is how it works. You work on the catapult by pulling the catapult. So work done by you on the catapult. So catapult gets potential energy. When you release it, the potential energy of that particular catapult makes it restoring, come back to its original position. But in turn, it does work on the pebble and the pebble is moved. So that is how the work is done by the catapult on the stone. A stone placed at a height has the potential energy stored in it. The stone that has this energy because of its position of the height. In figure 4.14, the stone is dropped on a nail fixed on a piece of wood. It drives the nail into the wood as shown due to its potential energy. So if I got a nail, suppose this is the nail and this is like this, and this is the stone. So this stone which I put over here, when I put this this stone has got potential energy. So when this stone is going to be released, it is going to hit over here and it is driving the nail inside. So this driving of the nail inside over here is done by the potential energy. So this, when I put it over here, this dust has got potential energy. When this is released, the potential energy is going to get decreased and it is going to do work on the nail and the nail gets drawn into the wood. So that is how the potential energy of the hammer is being used, or the stone is being used. The next is in figure 4.15, a falling stone when reaches a pan attached on one end of the pulley lifts up weight as it a falling stone when reaches a pan attached at one end of the pulley lifts up a weight at its other end because of its potential energy. So they have taken a pulley and they have taken a rope On one side there is one load, and other side one stone. So if the stone is heavier, what will happen? If I release the stone, if I'm holding it earlier, but if I release it, the stone is going to go downwards. So when this goes downwards, automatically this load is going to lift upwards. So on movement of the stone like this, there will be an upward movement of the weight over here. So that's what I say, that the falling stone, when reaches a pan attached at one end, so this pan is attached on another, on one side is a pan, lifts up the weight as it, so as the stone goes down, the weight which is attached to the other side of the string is going to move upwards. Water at a height has the potential energy stored in it. Falling water from the height can be used to do work like turning a wheel. So when the water is falling, the water will turn a turbine or the wheel, and the movement of the wheel is going to move some another part, and accordingly there will be the changeover from potential energy stored in the water into any other work done on the wheel. So do you know the potential energy is in two form? Elastic potential energy, when the work done on the body changes the size or shape. So as I told you earlier also, when I change the size or shape of the body, so that was in case of a stretched bow and arrow or the elastic, that is nothing but elastic potential energy. And when it is going to move towards the gravity, then it is the gravitational potential energy. So gravitational potential energy, when the work is done to a body, to move a body to a height above the earth's surface. So when I am moving any body above the earth's surface, then the energy possessed by the body is gravitational potential energy. But if I am changing its position, or like bow and arrow gaya to stretched rubber band वगैरह, so at that time I am changing its position, and that is the elastic potential energy. Now we see the expression for the gravitational potential energy. When a stone is lifted from the ground to a height, work is done against the force of gravity. This work is stored in the stone in the form of gravitational potential energy. That we understood too many times, so that's fine. Gravitational potential of a body at a height above the ground is measured by the amount of work done in moving it up to the height against the force of gravity on the body. So what is the amount of potential energy present in this body? So the amount of potential energy present in the body is equal to the work done in moving this body from here to here. So work done is equals to the energy. We already know the work done is equal to energy. So work done on moving this body from here to here is nothing but the energy possessed by the body over here. So that is what we know. So let the mass of the body be m, be moved from the ground level to a height h. The minimum upward force needed to move the body will be the force of gravity on the body will acting vertically downwards. So we very well know now that what we have is mass of the body, which is equals to m, and we know that the height to which the body is moved is h. So the body which was originally at this point is moved, this is mass m, and it is moved from this point to this point. The distance from this point to this point is h. So we are taking it as h, and the minimum amount of force required to move it from here to here is the work done against the gravity, because मैंने क्या किया, मैंने इसको सिर्फ उठा के इधर करना. So at that time, what is the thing which is holding it downwards? It is the gravitational pull. So whatever force will be required will be should be equal to the force of gravity. अगर मेरा force gravitational force से ज़्यादा है, only then I can lift it upwards, right? So that's why we see that the minimum upward force needed to move the body will be the force of gravity on the body acting vertically downwards. If G is the force of gravity, so the force of gravity is equals to G. So the force of gravity is equals to G on the mass of 1 kg. The force of gravity on mass m will be, of course, m kg. So you see that if the force of gravity is G for 1 kg mass, therefore for m kg mass, it will be equal to m into G. Okay, G is for 1 kg mass, 9.8 is for 1 kg mass. So अगर 9.8 का 5 kg रहेगा तो क्या होगा, 5 into 9.8. इसीलिए the amount of force required, force will be equal to m into G is equals to the force required will be m into g. And what is the distance traveled? Distance traveled is equals to d, is equal to h. See, the body was made to move from this point to this point with the distance h. So accordingly, see, the force is m into g and d, distance is h. So in the formula of work, what is the formula of work? Work is equals to F into d. So F is m into g and h is nothing but d is equal to h. Therefore, the work done, that is nothing but the potential energy or U is equals to mgh. Samjha? Force for 1 kg is g. So m kgs will be mg. Right? Distance traveled is height, which is h. So we know work is equals to force into distance traveled. Force is m into g and distance traveled is h. Hence the work done is mgh. But work done over here is equal to the potential energy attained by the body. Work done on moving in body from here to here is equal to the potential energy of the body. Hence the potential energy of the body is mgh. So force needed, F is equal to mg. Distance moved, d is equal to h. Work done is the force into distance moved, mgh. This work done against the force of gravity is stored in the body at a height h in the form of gravitational potential energy. Hence gravitational potential energy Pe or U is mgh. The SI unit of potential energy is joule, so that remains as it is. Thus the potential energy of the body is in the raised position depends upon the following two factors. What are the two factors? Mass of the body and the height of the body. So first one, the mass of the body. Greater the mass of the body, greater is the potential energy. Its height above the ground, higher the potential height of the body, greater is the potential energy. If I move it from here to here, potential कम हो जाएगा. पर अगर मैं उसको यहाँ तक लिया, potential बढ़ जाएगा. So जितना उसको ऊपर लेके जाऊँगा, potential बढ़ते जाएगा, potential energy बढ़ते जाएगा. If I take this, the mass is this much, but if I add to this some pens over here, the mass increased, the potential energy increases. So potential energy is dependent on mass and height. Okay, gravitational potential energy is dependent on mass of the body and height of the ground. Example, the potential energy of a bucket of water of mass 20 kg at the first floor of the house is more, that is double, than the potential energy of a bucket of mass 10 kgs at the same floor. अगर first floor पे 20 kg का ये रहेगा या 10 kg का रहेगा, तो of course 20 kg का potential energy will be more than the 10 kg bucket. Okay, so more the mass, more the potential energy. Similarly, the potential energy of a bucket of mass 10 kg at the second floor of the house at height 6 meter is more or double than the potential energy of the same bucket of the water at 10 kgs at the first floor, which is at 3 meters. So 3 मीटर पे एक बकेट पड़ा है 10 kg का और सेकेंड फ्लोर पे यानी 6 मीटर पे खड़ा है, तो ऑटोमेटिकली जो 6 मीटर पे है उसका पोटेंशियल एनर्जी 3 मीटर्स वाले से ज़्यादा होगा. सो मोर द हाइट, more the potential energy. Okay, so this was the explanation about potential energy. We will take up the kinetic energy in the next video. Thank you.